Good afternoon. Today we're going to resume working with inequalities, and for what we have in the most recent items, okay, we've had crossing over to rational inequalities, and just from the set of exercises from section 2.6, okay, where we have rational inequalities involved, okay, we have for problem number 60. And we have a set of comparison to zero inequalities, okay, where we have working with a rational function, okay, and so we have for the rational function, and we'll call this r of x, and for the ratio of concerns, okay, we're looking at x plus 4 all over x minus 1 and setting up a table of intervals, okay, involving this particular function, just like what we have had with the polynomial inequalities. Okay, we're going to establish the zeros involved. And now for the numerator and denominator, okay, both locations have an expression in x, and if I go ahead and take the zeros, both x plus 4 and x minus 1, we have for x plus 4 is equal to 0, we're going to have that x is equal to negative 4. As for x minus 1, okay, we're going to have that x is equal to 1. And for the zeros of r of x, okay, so yeah, first of all we have negative 4, and this value, okay, if I were to plug in negative 4 for x, I have like negative 4 plus 4 is 0, negative 4 minus 1 is negative 5, and 0 over negative 5 will go to 0. So negative 4 is going to be in the domain. Okay, so you can have a 0 numerator without having a 0 denominator. Okay. Now for the other 0 that we have at 1, okay, if I plugged in 1 for x, I'll have 1 plus 4 is 5 in the numerator, and the denominator, 1 minus 1 goes to 0. So I can have a 0 numerator, but I cannot have a 0 valued denominator. So we have for the value of 1, that 0 causes the expression to be undefined. Okay, and so for 1, I would say NITD for not in the domain. And if we establish a table of intervals, okay, and so we have in creating the spread here, okay, so you have two distinct zeros, okay, with negative 4 and 1. And okay, so for the first interval, okay, for the smallest values in x, we have those to be less than the smaller of the exclusions, or I should say the zeros, which we have in negative 4. So we have values of x less than negative 4. And bypassing negative 4, we have for the next interval, we have those values of x such that negative 4 is less than x is less than 1. And we have for the rest, we have those values of x which will be greater than 1. And looking at what we have for testing out any value selected among these intervals. Okay, so for values of x less than negative 4, I can take as a sample anything less than negative 4, and we could go with, say, negative 5. Anything between negative 4 and 1, okay, you can choose anything from negative 3 to 0. Okay, so that will go with 0 in this case. And then for the last, I can go with any value greater than 1. Okay, and I'll just go with 2 on this one. Okay. And it can be other values just as long as they fit the description in accordance with the interval immediately above. Okay, so we have with our rational function, okay, so we have x plus 4 all over x minus 1 And looking at what we have with x at -5. Okay, so we got -5 plus 4. We have all over -5 minus 1. And -5 plus 4, okay, that'll be -1. -5 minus 1 is going to be a -6. And in the case of a negative over a negative, okay, that is going to revert to a positive. Okay, so with x at -5, okay, we have the corresponding function value to be at positive 1/6. Now for what we have in the case of r of 0. Okay, so for x plus 4, okay, we have 0 plus 4. And for x minus 1, we have 0 minus 1. So we have 4 over -1. And so that will go to -4. As for what we have in the case of r of 2. Okay, so just plugging against it, we have 2 plus 4 over 2 minus 1. 2 plus 4 is 6. 2 minus 1 is 1. And we have a 6 to 1 ratio. So this is going to go to positive 6. And for what we have in the sign values of the function r of x, so for anything less than -4 that is selected for the input, the output is going to be positive. Okay, so we have the r of x is greater than 0. Anything in x such that -4 is less than x is less than 1, okay, we'll have a negative output. So we're going to have the r of x is less than 0, and then anything selected for the input that is higher than 1, we have the output to be positive. So we have r of x is greater than 0. Okay. And looking at how things are going to take shape, and looking at what we have for the inequalities, okay, and there'll be a bit of a jumbled order. And for part A, okay, we're starting out with an inequality that contains the equal sign. And in this one, for part A, we have x plus 4 all over x minus 1 is less than or equal to 0. And so for this inequality, okay, so we have r of x at x plus 4 over x minus 1. So we're looking at where r of x is less than or equal to 0. And we have in the same direction as where r of x is less than 0. So you have where r of x is less than 0, you're involving the limit values, -4 and 1. So for what we're going to have in the case of the solution, for starters, okay, so we're looking at working with -4 and 1. Now the inequality, okay, now we have the equal sign, and this signals that we might have a bracket. Okay, if I didn't have the equal sign, automatically, if there were any interval solutions, we would have just parentheses. And now for the equal to 0 part, okay, you can only put a bracket around the 0 that is in the domain. Okay, so -4 is in the domain, 1 is not in the domain. So for what we're going to have in this solution, okay, we have for the limits of -4 and 1, only -4 is going to be bracketed, because that is at least in the domain and sets the function equal to 0. But since 1 creates an undefined ratio, as opposed to setting the ratio equal to 0, that's going to remain in the parentheses. And for what we have in the case of the function being less than 0, and we're looking at the same, working around the same limits. Again, less than 0. Okay, so you have where r of x is less than 0. Then we have for the solution, again, so you have parentheses only around -4 and 1. Now for what we have in the case of part C, okay, now we're going in the other direction, whereupon we have x plus 1, make that x plus 4 over x minus 1 is greater than or equal to 0. Okay, so we're looking at where r of x is greater than or equal to 0. And again, with the equal sign, okay, there is a possibility of the bracket inclusion. Okay, so we have in the same direction as where r of x is greater than 0. So we're looking at the limit values. Okay, where we have at the front, we have between -infinity and -4, and also between 1 and infinity. Okay, and again, just closing out. Okay, so once again, infinities are boundless. So we'll maintain the use of parentheses. Okay, and again, -4 is in the domain, so that'll be in the bracket. And once again, 1 is not in the domain, so that cannot set the ratio equal to 0. And once again, that will be in the parenthesis. And then we have with our remaining situation. Okay, so you have where x plus 4 over x minus 1 is greater than 0. A lot of repetition from part C, except we don't have the equal sign involved. Okay, so you have r of x is greater than 0. And for the solution, it'll be the same numbers, but the exclusive use of parentheses. Okay, so again, we'll have those values of x less than -4, along with those values of x greater than 1. All right. So for less than or equal to 0, less than 0, greater than or equal to, as well as greater than 0, these will be respective interval solutions. All right. Now, in the crossover to where we have just solving for a single inequality statement, and we have for the case in number 64. Okay, so we got for this inequality, now we have 2 minus x all over x plus 6 is greater than or equal to 0. And okay, so just working with what we have here. Okay, so we got the function r of x is equal to 2 minus x all over x plus 6. And if we go ahead and obtain the zeros of the numerator and denominator. Okay, so if I have 2 minus x equal to 0, now I isolate the x terms, so I have -x, and moving 2 over, I have -x is equal to -2, changing the sign at both ends. We have the x is equal to 2. And for what we have in the case of x plus 6, if x plus 6 is equal to 0, and we have that x is equal to -6. So we have with this rational function. Okay, we have again 2 zeros. Okay, and the first, in case you have 2, and that is going to be attained from, once again, the numerator, and I can have a 0 numerator, so 2 is going to be in the domain. And again, with -6, that creates, instead of a 0 numerator, okay, we have a 0 denominator, okay, which is, again, taboo, okay, when working with the real number system. Okay, so -6 is not in the domain. And again, just looking at setting up a table of intervals. Okay, so we have in the layout. Okay, so between 2 and -6. Okay, -6 is the smaller of the zeros. So for the least values in x, okay, so we're going from -infinity and approaching, but not including -6. -6 will be bypassed. And for the middle interval section, we have those values of x such that -6 is less than x is less than 2. And then for the next portion, we have for the remainder of the possible values of x, it'll be those that will be greater than 2. Right. And looking at taking test values for the input. Okay, so anything less than -6, one might go with -7. Between -6 and 2, we can use 0 again. And anything greater than 2, one might choose 3 as the input. And for the rational function, again, we have 2 minus x all over x plus 6. And for r of -7, okay, so we're looking at 2 minus -7 all over -7 plus 6. 2 minus -7 would be 2 plus 7. -7 plus 6 is -1. And so for r of -7, okay, that is going to reduce to -9. And for r of 0, okay, so you have 2 minus 0 all over 0 plus 6. So you have 2 minus 0 is 2, 0 plus 6 is 6, and 2 6 is reducible to positive 1/3. Now for what we have in the case of r of 3, so we have 2 minus 3 all over 3 plus 6. And 2 minus 3 is -1. 3 plus 6 is 9. Okay, so we already have -1/9. And looking at the sign of r of x, okay, so for values of the input less than -6, okay, we'll have lead to a negative output. So we're going to have the r of x is less than 0. Anything greater than -6 and less than 2, the output is going to be positive. So we have the r of x is greater than 0, and then we have for values of x greater than 2, the output will be negative. So again, we're going to have the r of x is less than 0. And so looking at what we have in the mix, again, so the inequality we started out with Okay, it was 2 minus x over x plus 6 is greater than or equal to 0. And this is going to be in line with r of x is greater than or equal to 0. Now for what we'll have in the case of the solution. Okay, same direction as r of x is greater than 0, so we are looking at involving the limit values of -6 and 2. Now we got the equal sign, so there could be the potential for a bracket. Okay, so for this ratio, okay, we have for greater than or equal to 0. Okay, so again, for zeros in the domain, they can be bracketed. Those that are not stay in the parentheses. Okay, so for -6 is not in the domain, so it'll be contained by the parenthesis. 2 on the other hand is in the domain, and so we can put this in a bracket, and that will be the interval solution for what we have in the case of number 64. Now, for what we have in the case of changing up the variable, we have for number 80, we have a comparison of ratios. Okay, and here we have 2 over, instead of x, we'll have z minus 1. And this is said to be greater than -4 over z. Now, from the start, we've been working with comparing to 0. And now, between the ratios, I'm going to transform this statement to one where we're going to end up with 0 on the right-hand side. So I'm going to do it here with -4 over z. I'm going to move this fraction over by adding. So you have 2 minus z, and what is going to be plus 4 over z. Is greater than 0. And what I'm going to do is I'm going to make this sum into a combined rational expression. So I'm going to work to the side here. So we've got 2 over z minus 1 plus 4 over z. Again, we have with the least common denominator. Okay, so that's going to be z times, okay, the quantity of z minus 1. And again, if I combine these fractions, okay, so I have 2 over z minus 1. So we've got the z minus 1 factor, but we're missing the z. So I'm going to multiply this ratio by 1 in the form of z over itself. Now for 4 over z, okay, and pertaining to what we have in the least common denominator, we had the z factor, but we don't have the z minus 1. So I'm going to multiply by 1 in the form of z minus 1 over itself. And now looking at what is present. Okay, so we have 2z. You see I have all over z times the quantity of z minus 1. Second ratio case, I have z times the quantity of z minus 1. And distributing, okay, what we have in the second set of numerators, we have 4 times all of z minus 1. So this is going to be 4z minus 4. And I have the same denominator. So I can just consolidate the numerator terms. and putting together. Okay, so you got 2z plus 4z. Okay, so this will make 6z minus 4. And we have all over the quantity of z times z minus 1. Okay, so for what we have in the transitioning, okay, so had a comparison of ratios, then I wrote this as a sum of ratios compared to 0, and then putting this operation and consolidating. Okay, so this comes down to 6z minus 4 all over z times the quantity of z minus 1 is greater than 0. So we'll be working around this function and establishing a table that will center around, okay, the zeros attained from the factors in the numerator and denominator. Okay, so for right now, we'll have r of z is equal to 6z minus 4 all over z times the quantity of z minus 1. And for what we have from the start, okay, so if I attain the 0 from the numerator, okay, so I have 6z minus 4 is equal to 0. If I move the 4 over, so about 6z is equal to 4, and we have with division by 6, we have that z is equal to 4/6, and for this ratio, okay, we can reduce this all the way down to 2/3. And for the factors in the denominator, okay, so you have z automatically, so that is equal to 0, and for z minus 1, if that is equal to 0, well, we have that z is equal to 1. And for the zeros, okay, so we got our consolidated rational function. And for the zeros of r of z, okay, so you got 2/3, okay, and that will set the function equal to 0, since 0 is going to apply to the top part. So 2/3 is going to be in the domain. And as for the others, okay, we have a 0 as well as 1. Okay, these create 0 denominator values. So 0 is not in the domain. And you have that 1 is also not in the domain. Now, with the nature of the inequality being greater than, okay, it really does not demand the attainment of or identification of what's in the domain and what is not, but I'm going to throw in a special case. Now, for what we have in the case of setting up our table, okay, and so we got here. So I'm going to widen this table and add another interval, since we now have 3 zeros as opposed to just 2. Okay. I'm just changing up the variable. Okay, so I'm going from x to z. Okay, so we got 3 distinct zeros. Okay, and so for the first interval, we got 2/3, 0, and 1, 0 being the smallest. So you have the same set of values x less than 0 and bypassing 0. Okay, the next smallest of 0 is going to be 2/3. And then we have with 2/3, okay, bypass, okay, we'll have another interval, okay, so when we end up approaching 1, so you have from 0 to 2/3, you have from 2/3 to 1. And then we have, I'm just going to widen this. And with 1 as the third and remaining 0. Okay, so we have rest of the set will be those values of z which will be greater than 1. There we go. All right, so just for test values in z, okay, anything that is less than 0, okay, I like using the number 0, but I cannot this time around. Okay, so anything this I had to pick a number less than, I'm going to go with, say, -1. And we have with between 0 and 2/3, and go with just about most any value that is less than, say, 0.67. I'll go with the fraction here. I'll just go with 1/3. And then anything beyond 2/3 but less than 1. Okay, I'll just go with, say, a decimal. I'll just go with, say, I'll say 0.8. I'll tell you what, I'll do a decimal here as well. Instead of 1/3, I'll go with 0.5. And for anything greater than 1, I'll just go with the number 2. Okay. So we have for r of z, okay, we have 6z minus 4. All over z times, okay, the quantity z minus 1. Okay. And for the corresponding function values, for the inputs, okay, we'll start out with the integers. So for -1, we got 6 times -1 minus 4. Okay, so that's going to be -10 over, and then -1 times -2. That's going to be a positive 2. Okay, and so we're going to end up with -10 over 2. So for r of -1, okay, this is going to be a -5. And working with r of 2, 6 times 2 is 12 minus 4 is 8. And we got 2 times 2 minus 1, so that's going to be 8 over 2. And 8 over 2, okay, that's going to go to a positive 4. Okay, and we have with the decimals. Okay, so you got 6 times a half is going to be, let's see, 3 minus 4. So that'd be -1. And then you have 1/2 times -1/2. Yeah, so it'll be -1/4. -1 over -0.25. Okay, that's going to go to a +4. And for r of 0.8, okay, So we got with 0.8, so you got 6 times 0.8 is 4.8 minus 4. So you got 0.8. And you got 0.8 times 0.8 minus 1, so that's going to be 0.8 times negative 0.2, so it'll be a minus 0.16. And that's going to result as a negative 5-to-1 ratio. All right. And for the sign of R of Z, okay, so anything that is negative selected for the input, the output is going to be negative. So we have the R of Z is less than 0. Anything between 0 and 2/3, the output is going to be positive. So you have R of Z is positive. Anything greater than 2/3 and less than 1 for the input, the output is going to be negative. So you have R of Z is less than 0, and then for values of Z greater than 1, the output is going to be positive. So we have the R of Z is greater than 0. Okay. And just taking what we have, once again, we started out with this inequality. We had a comparison of ratios, then transform to comparison to 0. And we'll do here. Okay, so we start out with 2 over Z minus 1 is greater than negative 4 over Z. And once I move the 4 over Z over, we have 2 over Z minus 1 plus 4 over Z is greater than 0. And consolidating the ratios. So again, we had 6Z minus 4 all over Z times the quantity of Z minus 1 is greater than 0. So this is going to be partaking of where R of Z is greater than 0. And so for what we will have in the case of the solution, okay, so where R of Z is greater than 0, okay, there's no equal to sign in this case, right? So where R of Z is greater than 0, we're looking at those values of Z greater than 0 and less than 2/3. And also have R of Z to be greater than 0 for those values of Z greater than 1. So this is going to be the interval solution in this case. Now, let me mention if the problem had been with the equal sign included, if the problem had been given as 2 over Z minus 1 is greater than or equal to negative 4 over Z, okay, this would come down to where we have R of Z is greater than or equal to 0, and for that particular solution set, okay, we're still involving the same numerical values, okay, but again, with the equal sign, there is the possibility for the existence of at least a bracket, okay, and okay, so again, infinities are balanced, so we got infinity here, and okay, so in terms of being able to bracket, okay, zeros in a rational expression, we'll have greater than or equal to, less than or equal to statements. You can only place brackets around the zero or zeros in the domain, and only 2/3 is in the domain, so it'll be closed in the bracket. Whereas 0 and 1, again, they created zero denominators. Okay. And so with 0 and 1 not in the domain, okay, those values will be once again placed in parentheses. All right. So that would be the complexion of how the interval solution would come about if we had the equal sign and this particular inequality. All right. Now, for what we have, okay, so working with rational expressions, and just a couple of items. And the second, just want to give a little bit of an introduction or a bit of a segue in terms of how to go about following through Okay, so if you're looking at solving for x in interval format, now we'll say we have, first of all, we'll say that we have, in the inequality, we'll say that we have x plus 7 over x squared minus 4 is greater than or equal to 0. Now, just mention in the case of, let's say, a comparison inequality between ratios. If I have, say, that we have 2 over x plus 2 is less than or equal to 1 over x plus 4, and if I were to rewrite this once again as a comparison to 0 inequality, okay, so we have 2 over x plus 2 minus 1 over x plus 4 is less than or equal to 0. Okay, now if you notice, you have x plus 2, x plus 4, so you're going to have at least a couple of zeros with -2 and -4. But once you consolidate these ratios into one overall term, you might have an x expression in the numerator. So you could have the creation of yet another 0. And so just looking at, say, if I were to put together what we have in the difference, so you have 2 over x plus 2 and minus 1 over x plus 4. And for what we will have, again, for the least common denominator. Okay, so you have the quantity of x plus 2 times that of x plus 4. And looking at rewriting the ratios in terms of the least common denominator. Okay, so for 2 over x plus 2, okay, we have the x plus 2 factor and need the x plus 4 part. Okay, with the other, so you have got subtraction. Now we got 1 over x plus 4. For the least common denominator, okay, we have the x plus 4 part and need the x plus 2. So we'll multiply the second ratio by 1 in the form of x plus 2 over itself. Okay, so what I have right now, I got 2 over x plus 4. So yeah, 2x plus 8. Again, I have all over x plus 2 times the quantity of x plus 4. We've got the subtraction. Again, both ratios are now going to have the same denominator, which we have with the least common denominator. And for 1 over x plus 4, in terms of LCD, we got 1 times x plus 2. So you have x plus 2 all over x plus 2 times x plus 4. And this second ratio, again, is going to be subtracted. So once I put together, we have 2x plus 8. And the subtraction is going to affect not only x, but the whole binomial, x plus 2. Okay, so just looking at what we have upon distributing subtraction. Okay, so x plus 2, both will be subtracted, so we have negative x minus 2 and so we got 2x minus x becomes x. 8 minus 2 is going to be 6. Okay, so for what we have for this inequality statement, putting in the format of the standard layout for a single rational function compared to 0. So we got x plus 6 all over x plus 2. All of that times the quantity of x plus 4. Is less than or equal to 0. So I got the second part set up. So let's see what we get for the values of x such that x plus 7 over x squared minus 4 is greater than or equal to 0. And also what we have for x plus 6 over x plus 2 times x plus 4 is less than or equal to 0. And we'll discuss in the next few minutes. If you're still working on these, that's okay. Tell you what, we'll go ahead and establish the zeros for the first rational expression. Okay, so we have x plus 7 all over x squared minus 4. And again, so the nature of the inequality we have to be greater than or equal to 0. So with the equal sign, we're looking at separating the zeros that are in the domain apart from those that are not. Okay, so going ahead and identifying the zeros. Okay, so we have from the numerator from x plus 7, if I set this equal to 0, so we have x equal to negative 7. And for what we have in the denominator, if I set x squared minus 4 equal to 0, now we have a difference of squares I'll just go with the zero product property, but you could also use the square root property of equality, setting x squared equal to 4 and following through in that respect. Okay, so if we have from x squared minus 4, okay, with the factors from x plus 2 equal to 0, so we have x equal to negative 2. And with the other factor, x minus 2, setting that equal to 0, okay, we're going to have that x is equal to 2. All right. So we have 3 distinct zeros, okay, for this rational function. and for the zeros of r of x. Okay, so we have the first one, we have at -7. Again, this stems from the numerator factor, where you can have a 0 numerator while not having a 0 denominator. So for -7, okay, this one's going to be in the domain, so I'm just going to use ITD for in the domain. Whereas with negative and +2, those other zeros, those stem from x squared minus 4, which is located in the denominator, and those would cause the bottom part of the fraction to be 0, which is not in the set of real numbers. So -2, again, not in the domain. And 2, again, not in the domain. And looking at setting up a table of intervals. Okay. Okay, so just rank ordering. Okay, so we got -7 is the smallest of the zeros. Okay, all right, so the smallest set, we have those values of x less than -7, and next in line we have those values of x such that -7 is less than x, which is going to be less than -2. And we have bypassing -2, and we have next in line, so you have those values of x greater than -2 and less than 2. And then for the rest, you have those values of x greater than 2. Okay, so those would be the headings, okay, of what we have for this table. Okay, so we got the intervals. Okay, now we have for the next row. Okay, we're looking at selecting inputs. Okay, so for the test values, all right, so you have anything less than -7. Okay, we go with -8. Say between -7 and -2. We'll just go with -3 on this one. Between -2 and 2, yeah, 0 will fit. Anything greater than 2, we can just go with the number 3. All right. And looking at working with r of x. Again, r of x, we have x plus 7 over x squared minus 4. And for what we have in the case of r of -8. Okay, so you have -8 plus 7. Okay, so that's going to be -1. And -8 squared is 64 minus 4 is 60. So for r of -8, okay, this will come out to -1/60. Okay, now in the case of what we have with r of -3, so for r of -3, so you got -3 plus 7. Now we have all over the square of -3 minus 4. Okay, so you got -3 plus 7 is 4. -3 squared is 9 minus 4. So this will come out to a positive 4/5. And for r of 0, okay, so we have 0 plus 7 over 0 squared minus 4. And so we have 7, but it's going to be 7 over negative 4, in this case, negative 7/4. And for what we have in the case of r of 3, and this one case, we got 3 plus 7 over 3 squared minus 4. 3 plus 7 is 10. 3 squared is 9, minus 4 is 5. And so this will come out to positive 2. Right. And where we have for the remaining category, okay, for the sign of the rational function for each interval section, so we have for the sign of r of x, so anything selected less than negative 7 for the input, okay, the output is going to be negative. So you have r of x is less than 0, anything between negative 7 and negative 2 leads to a positive output. So you have the r of x is greater than 0, then we have next, we have a negative output. So we have the r of x is less than 0, and then any value of x selected greater than 2, okay, the output is going to be positive. Okay. And so for what we have in the case of the results, and relating back to what we had for the original inequality statement, again, so we have with x plus 7 over x squared minus 4 is greater than or equal to 0. And so now we're looking at where, okay, so you already had this lined up in comparison to 0. So we're now looking at where r of x is greater than or equal to 0. And so we'll have the same direction as where r of x is greater than 0. So we're looking at where we have greater than 0, so we're looking at involving the limit values, negative 7 and negative 2, as well as 2 and infinity. Now for the enclosures, okay, now infinities are boundless, so infinity stays in the parentheses. And looking at which of the zeros will be in the domain and which will not be. Okay, so we've got negative 7. That is in the domain, and with the inequality inclusive of the equal sign, we have negative 7 in the bracket. And once again, with negative and positive 2 not in the domain, okay, those values will stay in parentheses. And so this will be your interval solution for what we have here. Okay. Now, and looking at what we have with the second inequality, again, this had, went from 2 over x plus 2 is less than or equal to 1 over x plus 4, and we had this put or consolidate as x plus 6 all over x plus 2 times x plus 4 is less than or equal to 0. And just, so we got r of x in completely factored form. And we'll just go ahead and arrive at the zeros. So we have the zeros of r of x, say from x plus 6. We have negative 6. And since x plus 6 is in the numerator, okay, the 0 is going to be in the domain. And with x plus 2 and x plus 4 in the denominator, their zeros are not going to be in the domain. So negative 2 is not in the domain. Also, we have with x plus 4 in the denominator, we have the corresponding 0 value of negative 4 also not in the domain. And for what we have in terms of setting up our table, all right. And so just a little bit of a change up. We still have 4 distinct interval sections. Just like in the first case. Okay, so now we have with r of x, again we have x plus 6. All over the quantity of x plus 2 times x plus 4. And once again, in looking at what we have for the intervals. So we have 3 distinct zeros. Okay, so we got negative 6, negative 2, and negative 4. And okay, so if I start with the smallest amounts, okay, so we're looking at going from negative infinity to negative 6. And bypassing negative 6, I'm going past negative 6, approaching the next smallest 0 in this case, which will be negative 4. Bypassing negative 4, I have for the values of x, we have those values of x such that negative 4 is less than x is less than negative 2. And with negative 2 as the last of the zeros and being bypassed, we have the remaining interval section will be those values of x greater than negative 2. And for the tested values, I can supply anything less than negative 6, I'll just go with negative 7. And between negative 6 and negative 4, if I select an integer, I'm limited to just negative 5. Likewise, the interval selection for this third interval section, I'm limited to only negative 3. And anything greater than negative 2, I can just go with 0. Alright, so for r of negative 7, okay, so we got negative 7 plus 6, okay, so that'll be negative 1. And I got negative 7 plus 2 is negative 5. And negative 7 plus 4 is negative 3, so I got negative 5 times negative 3, so that's going to be negative 1 over 15. So we have negative 1/15. Now for r of negative 5, so I got negative 5 plus 6 is 1. Negative 5 plus 2 is negative 3. Negative 5 plus 4 is going to be negative 1. Yes, I got 1 over 3, so this will be a positive 1/3. And for what we have in the case of r of negative 3, okay, so we have negative 3 plus 6 is 3. negative 3 plus 2, again that is going to be negative 1. Negative 3 plus 4 is 1, so you got negative 1 times 1, so you have negative 1. So r of negative 3, this will go to minus 3. Now for r of 0, okay, so we have 0 plus 6 is 6, and we have 2 times 4 is 8, and 6/8 is reducible to positive 3/4. And so for the sign of r of x, first interval, we have a negative output. Second interval, we have a positive. Next, we have a negative. So you have r of x is less than 0, and then for the last, you have a positive, whereupon we have r of x is once again greater than 0. And so we have, in the case of the inequality we have started out with, so I had this comparison of ratios, and again just transitioning to what we have for the operation between the ratios in comparison to 0. We had this stage, and again upon consolidating, we had x plus 6 all over the product of the denominators less than or equal to 0. And again, this is our resulting r of x. So in the case of the solution, we'll be looking at referencing where we have r of x is less than or equal to 0. And so we're going to have for the solution, so we had the same directions where r of x is less than 0. So in the first section, say have between negative infinity and negative 6. And also have between negative 4 and negative 2. And again, we have the equal sign, so there is the possibility of brackets. So in closing, negative infinity, that is boundless, so you have a parenthesis. Negative 6 is in the domain, so that is going to be bracketed. Negative 4 as well as negative 2 not in the domain. And they will stay in parentheses. All right. And so this will be the interval solution of what we have for this last case here. All right. And again, so we'll be looking at pretty much wrapping things up from chapter 2, and over the weekend I do plan to send out a test 3 review study guide